This video is for class 9 physics, and today we are doing the numericals from exercise 4b, that is from the atmospheric pressure. Okay, without wasting any time, let's go to number 1. If you are worried about the formula, the formulas remain the same, which is P equals to H rho G, etc. Right? So here generally we will be using this formula P equals to H rho G for those 5 sums given to us. Okay, now convert 1 millimeter of mercury, height given to us is 1 millimeter, into Pascal. Take the density of mercury, which is rho, given to us here is 13.6 into 10 to the power 3 kilogram per meter cube, and the acceleration due to gravity given to us is 9.8 meter per second square. So using all these values, I am supposed to find the pressure using the formula P equals to H rho G. So let us go to its solution. Coming to the solution of number 1, here density of mercury given to us is 13.6 into 10 to the power 3 kilogram per meter cube, which is in the SI unit. So no issues, no problem. G is 9.8 meter per second square, again in the SI unit, but height given to us is 1 millimeter, and I'm supposed to convert this 1 millimeter into meter. And how will I do that? By dividing this 1 by 1000. This is how I convert 1 millimeter into meter. Now keeping the value same without converting it into a decimal number, we can proceed further. So using the formula, pressure equals to height into density into acceleration due to gravity, right? Here what I have done is I have replaced the values of H, rho and G, right? So now doing the normal calculations and normal cancellations, right? So this 1000 can cancel this 10 to the power 3, so the remaining numbers can be multiplied to get 133.8 Pascal, and that is our answer. I hope you understood number 1. Let us try to solve number 2. Reading question number 2. At a given place, a mercury barometer records a pressure of 0.70 meter of mercury, right? So height is given to us, which is 0.70 meter of mercury. What would be the height? Again they are asking us the height. What would be the height of water column if mercury in the barometer is replaced by water? So here the pressure exerted by the mercury and the pressure exerted by the water should be same, right? But the heights might be different because the density of water and the density of mercury is different. So let us try to solve this. Pressure recorded by mercury barometer is 0.70 meter of Hg, here meter, right? Meter. Please be very careful about this unit. Sometimes it is given in millimeter, sometimes in centimeter, and sometimes in meter, right? Okay, so the density of mercury here is 13.6 into 10 to the power 3 kilogram per meter cube. Both are in the SI unit, so no issues. Therefore pressure should be equal to H into rho into G, and then we can replace the values. Okay, so 0.70 meter height, density is 13.6 into 10 to the power 3 kilogram per meter cube. The last one, acceleration due to gravity, I'm keeping it as G. I'm not putting any numbers because it can get cancelled afterwards. Okay, let's go to the next line. The next line reads as pressure exerted by water column for the given height of mercury. Pressure exerted by water column now, right, for the given height of mercury. That means same pressure. That will be H into rho into G, but this time the height will not be 0.70 and the density will not be 13.6. We need to take the density of water. If it is not mentioned in the question, please remember that the density of water is 1000 kilogram per meter cube or 1 gram per centimeter cube, and into G, which is acceleration due to gravity. Okay, I hope you have understood till here. Now we need to equate this, and we can get the value of H because the pressure is same. Since both the pressures are same, right? So I can write H into rho into G for water, H into rho into G for water equals to H into rho into G for mercury, right? So now the cancellation starts. This 1000 kilogram per meter cube can cancel this 1000 kilogram per meter cube here, right? And then this G can cancel this G, right? So remaining H will be equal to this multiplied with this. So after the multiplication, I'm getting 9.52 meter, which is our answer. Hence, the height of the water column will be around 10 meter for 0.7 meter of mercury. So mercury has less density, more density. That's why the height becomes less. Okay, so I hope you have understood number 2. Let us go to number 3. Question number 3 reads as, at sea level atmospheric pressure is 76 centimeter of mercury. If air pressure falls by 10 millimeter of mercury, right? So you look here, the units are different. Okay, you need to be very careful about this. That's what I'm talking about. Okay, so 76 centimeter of mercury, if the air pressure falls by 10 millimeter of mercury per 120 meter of ascent, that means as we go up and move 120 meter from the sea level, right, this is sea level, then the pressure will decrease by 10 millimeter in the barometer. Okay, so what is the height of a hill where the barometer reads 70 centimeter of mercury? State the assumption made by you. Okay, let's try to solve this. Okay, the assumption part is given here only, the answer. Atmospheric pressure falls linearly with ascent. That means as we go up, the atmospheric pressure decreases. Okay, this is the assumption, but this should not be linear. Okay, as we have studied in the variation of atmospheric pressure uh, with the change in the altitude. Okay, so now this linear is just for this numerical problem. Okay, in reality is not linear. We have understood that, we have drawn a graph for that also. Okay, let's go to its solution. Coming to the solution of number 3, given pressure at sea level here, it's given as 76 centimeter of mercury, right? Let me change the color. 76 centimeter of mercury, and the pressure at a hill is 70 centimeter of mercury. So pressure has decreased by how much? If you subtract, we shall get 6 centimeter of mercury. So fall in pressure when you go up is 6 centimeter for this question, right? As pressure falls by 10 millimeter of mercury per 120 of ascent, okay, per 120 meter of ascent. That means if you go 120 meter up, the fall in pressure should be 10 millimeter, and right now we are having 6 centimeter. So here you can see we have the difference of unit. We have centimeter here and we have millimeter here. So let us convert this millimeter into centimeter. Now, so the same sentence can be written as, or pressure falls by 10 upon 10 centimeter. So this is how we are converting millimeter into centimeter. And what will be 10 centimeter upon 10 centimeter? Obviously it will be 1 centimeter, right? So 1 centimeter of mercury per 120 meter of ascent. That means if you go 120 meter up from the sea level, the fall in pressure should be 1 centimeter, but our fall in pressure, right, is 6 centimeter. Just now we calculated 6 centimeter. So if for 1 centimeter we have 120 meter, so for 6 centimeter how many meters will we have? Simply we need to multiply and get the answer. So 120 multiplied by 6, right, meter, that will be 720 meter, right here, 720 meter. So this is our answer, 720 meter. That means if we move 720 meters up, the fall in pressure should be 10 millimeter. Okay, I hope you have understood number 3. Coming to question number 4, you please do it by yourself. Okay, and Reading question number 5. Assuming the density of air to be 1.295 kilogram per meter cube, find the fall in the barometric height in the millimeter of mercury at a height of 107 meter above the sea level, taking the density of mercury as 13.6 into 10 to the power 3 kilogram per meter cube. Here, this problem also contains two types of materials, that is air and mercury, so it will be somewhat like number 2. Now here I shall find the pressure exerted by this amount of air column. That pressure will be equal to the same pressure exerted on the mercury column, right? So then we can find the height of the mercury column like number 2. Coming to the solution of number 5, given the density of air is 1.295 kilogram per meter cube, height of air, this is not here, okay, height of air, h, air is in the subscript, okay, so height of air column is equal to 107 meter. Pressure exerted by air should be equal to height of the air column, density of the air multiplied by acceleration due to gravity. So replacing the values, that is 107 meter, 1.295 kilogram per meter cube multiplied by g, like in number 2, this g will get cancelled. Okay, now going to the next line, density of mercury is also given, which is 13.6 into 10 to the power 3 kilogram per meter cube. Pressure exerted by the mercury column will be height of the mercury column, density of the mercury, and the acceleration due to gravity. Now replacing the values again, as you all know, we are supposed to find this particular thing here, okay, and the density of mercury is given, which is 13.6 into 10 to the power 3 kilogram per meter cube multiplied by acceleration due to gravity. Since both the pressures should be same, so here I am writing pressure exerted by the air should be pressure exerted by the mercury or on the mercury column, right? So 107 meter multiplied by 1.295 kilogram per meter cube multiplied by g is equal to height of mercury, density of mercury, and acceleration due to gravity. Now what I have done is I have done the cancellation. This unit and this unit gets cancelled, this g and this g also gets cancelled. Now doing the normal calculation, what will I get is I shall get this fraction here, which is equal to the height of the mercury column. Solving the fraction, okay, solving the fraction, I am not doing the solving part, the solving the fraction, ultimately I will get 10 millimeter. Please do the calculation by yourself. Okay, this much for this video. Thank you so much.